shiver comes down. Oh, she looks so good. Oh, meet in the woods, she sings shiver comes down now, 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 shiver comes down. Oh, she looks so good. Oh, meet in the woods, she sings
we go. Hopefully that transitioned over. Anyway, we're not expecting inheritance on your first assignment. We're expecting those 3 classes and then any ancillary classes, support classes, utility classes that you use eventually to load up data. We're on a 10-second delay. Okay, now we're good. All right. Glad I checked that. But anyway, I reverted our design back to something that used inheritance here, and I wanted to know how I did this. So this design right here, or this figure at least. And you'll see it on your like Lab 5 next week, but I just want to let you know that there are tools out there that allow you to generate these things. First of all, you can do it manually, like on app.diagrams.net, and you can draw things out. We're not expecting that. We're expecting you to do it on a piece of paper and take the picture of that, and as long as it's legible, we'll be able to give you feedback. But ultimately, once you've done your implementation and you've got your actual Java classes, you can go ahead and use Plant UML. That's what I'm using over here. This is a Plant UML that is integrated into Eclipse. This is a step-by-step instructions on how to install it and then use it. You can go ahead and highlight things over here. In fact, if you highlight an entire package, you'll get an entire picture here, diagram of what your entire project looks like. Again, we're not looking for that. We're looking for your hierarchy initially, on assignment 2, that is. But assignment 1, we're looking for a collection of what you're going to be implementing, right? Person, director, author, there we go. All right. So those will be in the notes as of today if you want to use them. Otherwise, they're already on GitHub, okay? All right, so coming back to where we introduced these ideas, that inheritance defines an is a relationship. Generally, that has to be an invariant, right? So a dog is always going to be an animal. A cat is always going to be an animal. An animal is not necessarily a dog or a cat, and a cat is never a dog, and a dog is never a cat. With our director and author, right? We initially thought, well, a director and an author, those are two different things, until we found a real-world counterexample, Stephen King, that was both of those things. So that had me rethinking my design, right? Anytime that you have a locked-in hierarchy like this, it's going to be very, very difficult to change it. So you have to make sure that it's correct up front. Always follow the is a relationship. If you've got A and B, A is a superclass and B is a subclass, if you're going to design it like that, B always has to follow that is a relationship. If you ever come across a counterexample, or you can think of a counterexample, then you probably don't want to do that. That is encapsulated in this figure right here. Right? Now, we're not using dog, cat, and animal. Instead, we're using bird, robin, and ostrich. Hopefully, we can all agree that a robin is a bird, an ostrich is a bird, but is a robin an ostrich? No, but not vice versa either. And is a bird always a robin? Right? No. What happens if it's an ostrich and we try to force it to become a robin? Those are three different types of relationships. Covariant, contravariant, and invariant. Covariant is always safe. You can always take a robin and you can always treat it like a bird, right? That's called covariance, right? So there are three types of relationships here. The covariance is the first type. And here I'm using dog again, right? You can always treat a subclass as a superclass because dog is always an animal. This is always safe, right? In fact, this is called subtype polymorphism. We'll get into polymorphism next week. But that's always going to be safe. Contravariant is where you're taking a bird and you're forcing it to become a subtype. That's contravariance. Now that's safe if you started out with an ostrich and then you treated them as a bird and then you forced them to become an ostrich again, right? Then that's sometimes safe. It's not always safe because if you started out with that robin and then you made it into a bird and then you forced it to become an ostrich, now you've got a problem there. And when we did that with the director and the person, we had a class cast exception on Wednesday. Right? It wasn't going to let us do that at runtime. Right? The contravariant is sometimes safe. What is never safe is the invariant type. Trying to treat a sibling class as one of its sibling classes, right? That is never going to be safe and never something that you should do. Right? Okay. So how do you avoid these kinds of things, right? Well, first of all, sometimes it's okay to perform a test before you do a contravariance, right? You can use instance of the instance of keyword to determine if it is of the appropriate type, right? So let's come back over to our code and see what I mean over here. Let's go back over here to this demo right here, this version of the demo over here. And I've got author, director, everything that we were working with on Wednesday here. And remember here that when I had David, right, he was a director. Let's see, where did I instantiate him up there? There we go. He was a person, but he was also a director. And so I knew that because I did that above. And I forced him to become a director again for the purposes of adding a film, right? That is kind of dangerous because I didn't know whether up front whether or not David was actually a director, right? So what you can do is you can add some code to test that. If David in instance of director, then the following is safe, right? There we go. Right? Else system.out.println David is not a director, right? Okay. So that's how you would go about doing that, but you almost should never do something like that, right? There's only one instance in which it's okay. But again, you can use the instance of keyword inside of an if statement to see if it is correct. However, you generally don't want to do this, right? You only do this if you have to do this for some reason. If you find yourself doing this very often, right? For example, I need to know if they're a director or if they're a person or if they're a author in order to determine how much to pay them, and that's going to be the theme of next week's lab, then you're doing something wrong, right? If I need to know somebody's an undergraduate student or a transfer student or a graduate student in order to give them a different fee for their registration or something like that, you're doing something wrong, right? That you're breaking encapsulation. That stuff should be inside the class, all right? The only time that you have to do this is where you're calling a constructor, right? Generally, the only time that you have to use instance of is when you have a contravariance, is when you're making copies of something. I've got this object, and I don't know what type it is because I want to clone it. I want to make a copy of it, a copy constructor. I need to know, is this thing a list or is this thing a set? Because I want to make another list or another set. And those two things are completely different. That's just like a robin and an ostrich is different, right? In fact, we can take a look at another diagram here. Let's see, the truncated inheritance this one right here, right? There we go. So we're all familiar with sets and lists, and they're all types of collections. We've looked at hash sets as the implementation of a set. We've looked at array lists as an implementation of a list, but we haven't looked at tree sets and linked lists. I'm just putting those in there as additional examples. We will look at those later, right? Well, in fact, we'll learn how to implement a tree set, a binary search tree, and also a linked list, because you're going to be doing your own linked lists, right? But otherwise, this is a well-defined hierarchy. What is an array list? Well, it's a list that holds things in an ordered manner and allowing duplicates. It's a collection, right? It's a collection of stuff that is stored in an ordered manner using an array, if you go from the top to the bottom. Well, what is a hash set? It is a collection of stuff that holds stuff in an unordered manner using a hash table underneath. Right? We're not going to cover hash tables, but it's more specificity. Up here, it's generic. Down here, it's very, very specific. I cannot take a set and treat it like a list. I cannot take a list and treat it like a set because we're in this inheritance hierarchy. That's an invariance, right? That would be an invariant, right? One of them is ordered and the other is not. But if you want to create a new list from a set, you can go ahead and do that using a copy constructor. And that is the only time where you would actually want to use, in fact, you'd have to use an instance of. By the way, we didn't have to do that when we were converting lists to sets and sets to lists, because all the copy constructors work on generic collections instead of specific lists and sets. Okay? But in your project, eventually, you're going to have to use instance of if you're creating copies of items or copies of people or something. Okay? All right. So to sum up, what are the motivations for inheritance? Right? It provides a way to utilize code reuse, right? We like code reuse. That's why we write functions to begin with. Now we're just doing it with data in an object-oriented programming manner, right? We like inheritance because we've got general behavior up here. All collections hold stuff, and so it has a getter, right? A way to retrieve something, a way to put something into the collection. But down here, lists hold stuff in a sorted manner, or in a ordered manner, I should say. And so we have a get the element at the ith index functionality over here. We have more specific functionality over here. We don't have that over here in set. You can't get the element at the ith index because there is no indexing. And then we've got even more specific behavior of how are you going to store your stuff, using an array or using a bunch of linked nodes. The way that a linked list works, here's a preview, is you've got this node that holds stuff, and it has a reference to the next node that holds stuff, and a next node that holds stuff. So you've got this long chain of elements, right? And there are use cases for both of these types of data structures, right? But otherwise, you can reuse code at the top and then provide specificity at the in the subclasses. It provides a way to reduce redundancy, right? It provides a way to organize your classes into a hierarchy. We do this all the time, right? What is it? King Philip comes over for dinner or something like that. What's the mnemonic device for kingdom, phylum, genus, species? There are 7 of them there or something, right? Whatever it was, right? We organize the natural world according to that taxonomy. We like organizing everything into a hierarchy because it provides general behavior up here. Everything lives. Well, does something live by, what is it? Plants and photosynthesis. There we go. Does it live by photosynthesis, or is it a predator, or is it a prey, right? Or something like that. It's a way to organize stuff. And so it's a way for us to organize our code into a hierarchy. If you have a well-designed hierarchy, the introduction of a new class will not break any of the other code. If you introduce a new type of item or a new type of account or a new type of person and it breaks everything, then you know that it was not well designed to begin with. You should be able to create a brand new class, fit it into your hierarchy wherever it belongs, and everything should work just as before. You just have to create this new class, okay? All right, so again, if you don't have a well-defined hierarchy, then you have a lot of problems. The is a relationship must be invariant or variant. You can't have a person that is sometimes a director and then sometimes an author, right? That's a bad hierarchy. Because once a hierarchy has been established and code is now dependent on the hierarchy, it cannot be changed without breaking all of your other code. Right? It can be changed, but not without breaking all other code. Right? Let me show you another diagram here. It's the same diagram as that collection, but it is way more detailed. Right? Here's the collections hierarchy. In fact, this hierarchy is even abridged of the actual hierarchy. Right? So imagine, this was designed 30 years ago, and thankfully it was well designed. Because imagine if it wasn't. We would have 30 years of code where, okay, no, we don't want this thing here anymore. We need to move it over there, right? Just like I did with director and person, right? And I decided I want to use composition now, right? If somebody decided that 10 years down the line, it would have broken the last 10 years of code. If somebody decides to try to change this today, well, they ain't going to change it. But if somebody wanted to change this today, they couldn't do it without breaking the last 30 years of code that all depends on this hierarchy, right? It is so locked in because once you lock in your hierarchy, that's it. It's got to be that way forever. So be careful on your design because you may need to go back and change your design, right? And by the way, there are some languages like that have no problem with breaking stuff. Right? Very conservative languages like C and Java, they bend over backwards to make sure, C makes only like a change every 10 years. And even when they do that, it's a very small change that doesn't make, that's still backwards compatible. Java, one of its founding principles was to make it backwards compatible so that nothing would break 30 years from now. Java code that was written 30 years ago can still be compiled and run on today's Java virtual machines. You can't say the same thing for a terrible language like PHP, where version 2 to 3 broke, version 3 to 4 broke, version 6 didn't even exist because nobody could agree on what breaks and what doesn't. And so they went immediately to 7, and that broke everything before it. Everything had to be a complete rewrite. Even a popular language like Python is not backwards compatible. There's a reason we have Python 2 and Python 3. Right? Python 3 is not backwards compatible with 2, and now 2 is dead. Right? So if you wrote any code in Python 2, and understand that it's reached the end of its support life, right? Nobody should be writing in Python 2 right now, right? But anyway, once it gets so complicated like this, and we'll talk about these 3 layers here in a second, once it gets so complicated, then you're locked into that hierarchy, right? So you have to have a well-designed hierarchy, okay? All right, let's do another demonstration here that's going to motivate that 3 layers demo, right? Let's go ahead and create some assets, some classes to support assets. In particular, I want a stock and an annuity. Right? So everybody knows what stock is, right? There's a company, and if it goes public, they sell stock in their company. You own a share of that, right? You can own 100 shares of Google stock. And Google, each share has a price. I don't know what it is up today, but maybe $100. $100 for a Google share. And so if you own 100 shares, then you own $10,000 of equity in Google, right? An annuity is a little bit different. An annuity, what you do is you take a chunk of money and you buy an annuity. That annuity then pays you a monthly dividend, right, for a certain number of years. So if I bought an annuity for $10,000 for 5 years at, let's see, you've got to make it worthwhile, say $1,000 a month, right? That would be $60,000, right? And that's actually a really good annuity because I only paid $10,000 for it. Annuities are almost never a good investment. You almost pay as much as you're going to get out of it. But there's a guarantee that it's going to be paid out, okay? So let's go ahead and close all of these, except for this demo over here. And let's go ahead and create a stock class, right? Stock, okay? And we're going to create an annuity class, annuity, okay? Let's go start with the stock class here first. What would I need here? What are 2 obvious things that I just talked about with a stock that should belong to this class? Pieces of data, that is. Yeah. All right, so private value would be the share price, double share price, right? So $150 for Google, right, per share, right? And then you said a quantity, so a number of shares, num shares, right? It's better. I mean, you can call it quantity, but what a quantity? But what does that mean in this context, right? Does it mean the total value of all of your shares, right? No, that's num shares, right? Okay. And why did I do a double here? Because you can own fractional shares, right? You can own 5.5 shares of Google stock, okay? What else might belong there? Yeah. Okay, so let's see, private string, ticker name, right? Or let's just go with name, right? For Google, that would be Google, or actually no, it's Alphabet, right? Alphabet or Abet or something. I don't know what it is, but. What is it? Oh, maybe they do. Goog. It's Alphabet Corporation. Who cares, right? Anyway, is there a difference between me owning 50 shares of Google stock and you owning 1,000 shares of Google stock? Yeah. So what's the operative piece of data there? An owner? Right. So what is an owner? A person. Okay. And guess what? We already have that. Right? Because we designed that before. Right? I am going to have to import it now because I'm in a different package, but code reuse. Once you've defined a person, that person can be a primary contact. It could be a salesperson. It could be a truck driver, right? Once you've got that person designed, you can reuse that all over your code. Hint, hint. Right? All right, so person, owner. Right? What else? So how do you know that I own that and you own that? You own that account number, basically, right? Private string, maybe an account number, okay? All right, that looks like a good start. We'll come back. Let's do some annuity over here. And remember I said that annuity pays you a monthly dividend. So private double monthly payment, right? That's a payment to you, right? And then private int num years. Right? We'll just say that you buy it for a full year. Right? It could be 1 year, 2 years, 3 years. In other words, the number of months in a year times 12, right, etc. What else does an annuity have? An owner, right? So Once again, private person owner. Right? Okay, and we're going to have to bring that in as well. Import that. Already I'm seeing redundancy. I've violated the DRY principle, right? The don't repeat yourself principle. Maybe there's a way we can utilize inheritance to reduce this redundancy. But before that, we do that, let me go ahead and add one more thing, an account number. Right? Number. Okay? So we've got some redundancy between these two things, right? In fact, if you want to put them side by side, what will it look like? I've got a redundancy here, and I've got a redundancy here. Right? Anytime you have, now's the time for a couple more IDE tricks here. If you want to compare them side by side, you can of course do what I just did, or you can go ahead and select them, right? Annuity and stock, right click, and where is it? Compare with each other. Right? And you get something that looks like this. Right? It highlights the differences. This is basically a get diff, right? And so you can see, oh, well, 7 and 8, those are exactly the same lines, right? Here's another trick that I was mentioning to somebody over email, right? Let's see, let's go with something old. Here's the isotope. I'm not going to compare it to anything except itself, right? Compare with local history. Even if you're not using Git or GitHub, your IDE will keep track of history. It's not a full Git repository, but it'll keep track of a history, hopefully. Cross your fingers and hopefully it does it, right? Because, of course, it's not going to keep it in perpetuity. If you delete the file, you might lose the history, blah, blah, blah. So if you've got, I want to compare it with something that I did on December 7th at 10:44 a.m. Double click on that. Uh-oh. Can't be compared. Okay, looks like those are all lost. And yeah, that can't be compared. So only this one from the 7th at 11:10 a.m., right? And then I can take a look at the differences there. Unfortunately, there's no differences. Right? So I'm kind of screwed if I wanted to look at a past instance of isotope, aren't I? If I had used Git and GitHub appropriately, I would not be screwed. Right? I would have a version in the cloud where I can pull out an entire version history. So eventually you're going to have to learn, everybody has to learn at some point that I just lost an entire homework. What should I have done? Use Git in GitHub. Or you can start using it now and never have to learn the lesson the hard way, right? So if you're interested in using Git and GitHub, make sure that you are watching video 0.2. Right? I walk you through how to do that, okay? Otherwise, again, comparing these two things, I have some redundancy here. In particular, I am redundant on these two pieces of data. Right? So this is a perfect example of where I could potentially use inheritance by creating another class, which I will call an account. Or these are both assets, right? Asset or account? Asset, account. Which one? Account? Okay. Remember, there are only two difficult things in computer science. One of them is cache invalidation, and the other is naming things. Right? So I'm going to take this account, and I'm going to take and promote the common features up to this account. I'm going to put up here account number and account. And then down here, instead of having my own versions of those, I'm going to extend account. That also relieves me of the need of importing the person over here because it's already imported in the superclass. Likewise, over in here in stock, I'm going to get rid of those, and I'm going to extend account, right, and get rid of that import. Right? I've reduced redundancy now. Now let's continue over here in the account because I do want a way to create things. Create, retrieve, update, and destroy. I want a way to have a constructor, right, using fields. Great, that works. Right? I want getters, maybe, and I don't want setters because I prefer immutable objects. But I do want all the getters, right? And maybe a toString method. toString, and then sure, we'll just go ahead and go with that for now. And account number, blah, 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 blah. You'd probably want to make that look pretty. Right? And then if you really want to go the full 9, you would also want the hash code and equals. It's just good practice to do so. Right? Because eventually you're going to want to use these in maybe a map or a hash set or a hash-based data structure, and that needs to have a hash code there. Right? Okay? I'm done with the design of that object except for I forgot my documentation. Right? So represents on account. an investment account. Right? Great. Should I have called this annuity account? Annuity account extends account. Annuity is an account, right? So it's redundancy. DRY, don't repeat yourself. To do, documentation. Right? All right, so it's complaining here because I don't have a constructor. So let's add that constructor. Constructors should go after the member variables. So shame on you for Eclipse for generating it incorrectly there, right? There we go. All right, does that look like a correct constructor? It's taking an account number and an owner, but is it taking these two other things? Nope. All right, so the auto-generated one is not what we want. Let's go back up here and generate constructors using fields and all of those things. And as well, hopefully it does yep, it automatically does the super constructor for me too. It takes an account number, an owner, a monthly payment, a number of years. Okay? All right, so leave myself a to-do, design the rest of this class. Getters, not setters. Right? ToString equals hash code, etc. Right? I left that as a to-do, which means a reminder to myself that I still need to do it over here in tasks. I've got a lot of to-dos here. Clean this up, clean this constructor up, finish this class, right? So make sure you've left all, once you're done, by the way, remove a to-do so that it's removed from the list. And also we don't want to see that, right? Okay. Let's come over here to stock. And, oh, thank you. Online praise, wonderful. If I had a Patreon, I'd put that up there. Anyway, Patreon still works, right? Okay. All right, so let's see. Go ahead and generate a constructor using fields here. I don't have a Patreon. Don't send me money. Right. There we go. There. Now we've taken care of that. Okay. So you can take account number, owner, name, share price, and number of shares. Now let's start doing stuff with it. So let's create some stocks. I would love to have 100 shares of Google. Stock is equal to new stock. And what is it going to take? It's going to take the account number. I'll just say 123 ABC. Right? It's going to take me, so I need to, of course, be a person here. Person P is equal to new person me, because I want to own this stuff. Right? And I do need to bring those in because they are in a different package. Right? And that's going to be me. And it's Google. Is it Goog? All right. And let's just say 100 shares. What's the share price? There's the shares. Did anybody look it up? 186.54. All right. Wow, I've got almost $20,000. Right? Right? Yeah, almost $20,000 there. Let's do another stock. What's your favorite stock? Google. Apple. There we go. And I'll do APP123. And that'll be APPL, I think. And what's Apple's stock right now? 244. Even? Okay. And let's say that I own 50.545 shares of that, just to demonstrate that you can have fractional shares. Right? Now let me give myself an annuity. Annuity. A1 is equal to new annuity. And it's going to have an account number, I don't know, 4444. Right? Me and what is it, monthly payment, and then number of years. So a monthly payment of, say, $1,000 for 5 years. What's the value of that annuity? $1,000 a month for 5 years. How many months in a year? So it'd be 60,000, right? 12 times 5, that's 60. And then $1,000 a month, that's $60,000. Let's go with another annuity. You got to spell it right, by the way. Right. And 2. And I'll go 5555. And then let's say that this is a smaller annuity of 100 bucks for, I don't know, 3 years. So 3 years is 36 months, so that's $3,600. Right. Except that, do you see any math here to compute all that? I don't see any math here. If I had to do that, I would have to say, what's my total? What am I worth here? Double. Total worth, right, is equal to 0. And then I'll say total worth plus equals Google dot get share price. Oh, I don't have getters, do I? Let's come over here to the stock. And I didn't put a to-do in there, so let me go ahead and generate getters. Right? And let's go all getters. And now I can compute my share price there. Dot get num shares times Google dot get share price. There we go. And I can do the same thing, but for Apple. Right? And I can do the same thing for the annuity. Does this seem right? Does this seem object-oriented? No. What have I done? Just like the isotope class, I've ripped it open to pull out the share price, the number of shares, and multiplied it here in this class. This breaks encapsulation. Do not do this. Right? In fact, I'm going to be so adamant about it, I'm going to leave that in the notes so that you remember. Don't do something like that. Big time design points off. Okay? So what should we do instead? The total value of a stock sounds like a blank thing. It belongs in the blank class. Fill in those blanks. Stock. The value of a stock that I own is a stock thing. It belongs in the stock class. So let's come over here and give it to this class. Public, double. Say get value, right? Do I have to pass anything in here? Do I have to pass in share price and num shares? Nope. Why? Because it is part of the state of the object. There will be nothing that I have to pass in here, right? Return this dot share price times this dot num shares. That sounds way better, right? Instead, my total worth now is, I'll do it below. Undo that. This is good, right? Apple, not get num shares, but get what? Get just the values, right? Also, from a code perspective, isn't it much simpler, right? You're putting that stuff into a function, and you're putting that function inside the class. You're now organizing on two different levels. Right? Now, before I start breaking encapsulation with annuity, what else should I do with that class now? Public, double, get value. What would the value be here for an annuity? This dot num years times 12 because it's a monthly thing times this dot monthly payment. Right? Okay. Now let me come over to the demo class and add my annuity worths. Right? There we go. And A1 and A2. Right? And I don't care. We can print it out. System.out.println total worth. Okay. There. All right. That's, well, here, it's not good. It's a little better. Right? Okay. What's even better than that? So I'm doing something 4 times. There should be what kind of a thing that does this? A loop, right? So this is a little better. What I'm going to do is I'm going to do a loop for each asset, for each, what do we call them? Account? For each account, right? For account A, right? In some collection, my accounts. I haven't written that yet, but I will. Right? I want something that looks like this. Total value, A, get value, and then I can print it out at the end. Right? There. Okay? Except that, do I have my accounts yet? No. All right, so let's come back up here, and let's go ahead and put them into a collection. Maybe a list of accounts. Right? My accounts is equal to new array list. Okay? Now, how do I get my accounts into there? My accounts.add Google. My accounts.add Apple. Right? My accounts.add annuity A1 and A2. Wait a second. I've got a list that's holding 2 different types of things, a stock and an annuity. Why does it work? What are both of these things? They are subclasses. Right? account, annuity, and stock is a relationship. An annuity is an account. A stock is an account. Right? It relieves me of having to have two different lists. Right? If I did this with a list of stocks, list of stock, my stocks, right? And list of annuity, my annuities, whatever, right? Then I'd have to keep them separate. Now what if I added a new type of class? And remember, if it's well designed, adding a new class should not break any of your other code. Now I'm going to add a new checking account, right, as an asset or an account, right? What happens now if I went with this strategy instead? I have another list, another list, another list. In other words, the introduction of a brand new class breaks everything that I wrote before. Whereas if I had used inheritance here, it doesn't break. Not only that, but I can have a simple loop to get everything done. We're not done yet because this is still not compiling. Let's go over to the account class, and does it have a getValue method? No. So let's add it. I usually add it after the boilerplate. That's a good question. Yeah, let's add it down here. All right. So public double get value. Okay. What do I return? So this is the superclass. The only thing in here is the account number and the owner. Is there enough to determine what this thing is or what the value of this thing is? Nope. That gets us back to this diagram here. You've used hash sets and array lists. You've also used sets and lists as their types, right? There are 3 layers here. Down here you have actual classes. Think of these as concrete classes. Something is concrete if you can hold it in your hand. I've got my headphones here. This is a concrete idea, right? But if I just said headphones, right? Could you hold the idea of headphones in your hand? No, the idea of headphones is an abstraction. Do you mean the Bang & Olufsen's? Do you mean the Sennheisers? Do you mean the Philips, right? And even if you've got a brand in mind, do you have a specific model in mind, right? No, that's when it gets down to actual concrete ideas. So what we have here above that is an abstraction, the abstract idea of what it means to be a collection or a set or a list. Even above that, we have something called interfaces, which are pure abstractions, right? So you're going from concrete ideas to a little bit more abstract ideas to absolute pure abstract ideas, right? That's what we're going to do over here in account. Because what you can do is you can come over here. By the way, it now compiles because this doesn't compile, right? But over here, I can create an account, right? Just a generic account. Account C is equal to new account. Right? And I need the owner and the account number. This should not exist. Right, there we go. As a strong hint that should I be able to do this, it's just a generic account. Nope, because when I come down here and ask questions about what's your value, you end up being forced to do one of two things. You end up being forced to do either a dummy value. Well, this is just the idea of an account. It's worth nothing, right? 0. Or you're forced to throw a new runtime exception. Right? I don't know. Right there. Okay. Now it compiles, but is this going to run over here to print out the total value? Oh, it does. Oh, because I didn't put it in the collection. There we go. So let's go ahead and go with my accounts dot add generic. All right, there we go. Now it'll fail because I don't know, right? What do I add to this? Now it's a little bit better if you just return 0, but still that's not all that satisfying. So should we even be able to create the idea or be able to create an account if we don't have enough information to determine its value, right? We can determine the owner, we can determine the account number, but we don't have any other information about it. So that is a perfect use case to make it abstract. And that's what I'm going to do. I'm going to come up here and public abstract class, abstract class. Now, two things happen. First of all, this code breaks over here. You can no longer create an instance of an abstract class, right? Just like if you have the idea of an apple, right? Well, okay, there's that apple over there, and that apple over there, and that apple over there, but just the idea of an apple, right? The quintessential example, or Plato called that the Platonic, or we call that the Platonic ideal, right? In philosophy, right? The example, the perfect example is a circle. Does the perfect circle exist? No. Mathematically, it exists as an abstract idea. But if you tried to draw a circle up on the whiteboard, it's nothing more, well, first of all, yeah, can you do it very well? But also, it's nothing more than a collection of ink blots, right? It's not a circle. If you do it on a computer, the computer can do it perfectly, but it's just a collection of pixels, right? The ideal, the quintessential example does not exist. So we should not allow it to exist, okay? And down here, when I add it, now that goes away too, right? But otherwise, the second thing that happens here is that now I have a solution, a better solution to this. Instead of saying I don't know, or instead of returning a dummy value here, I'll make it into an abstract method, right? I'm going to get rid of all of this. There we go. Right? I don't know how to implement this, because with stocks I know how to implement it. With annuities I know how to implement it. But with just a generic account, I don't know. I don't know how to compute this. Right? And by the way, that does require documentation to do document. Right? Even though it doesn't have an implementation, right? It still it returns here. Let's just do it. Returns the value of this account. Right? That's all you need. You don't need to get fancy, but you do need documentation. Okay. But that's an abstraction. An annuity cannot be an abstract class. Right? I mean, it can be here, but if you have, let me get rid of that for a second and show you the difference here. If you have a concrete class, and we don't have the keyword concrete, it's just the absence of the keyword abstract, right? And you don't have a method that overrides that abstract method, then it doesn't compile. It says that you need to add this unimplemented method called get value here. Right? So those are the consequences of an abstract class. Right? Okay? So questions on that? Otherwise, by the way, everything works over here now. Right? And this is an ideal implementation. Let me go ahead and grab everything. And once again, let's look at plant UML here. Right? Unfortunately, I don't know why, but it doesn't render this correctly. This actually should be an A, right, for abstract. Don't worry about it, right? If it doesn't render when you use plant UML, fine, right? But it is an abstract class. And then we've got a demo class over here that uses these things, but we've got an annuity class and a stock class. And one way that you do know that it's an abstract class, if you look really, really closely here, I think I can zoom in. Yeah, I can zoom in or out. There we go. Get value. It's italicized, meaning that it's abstract. I don't know. It doesn't have an implementation. But down over here, it does. Right? Yeah?
You want us to re-document the abstract functions, the abstract methods inside of the subclasses?
Oh, that's a good point. Probably. All right. I mean, it's simple enough here. Returns the value of this account, of this stock, right? Or of this annuity. That is the total payout over the life of the annuity, right? That's good enough, right? Something like that, right? Again, don't get fancy. Just, it does what it says on the tin, right? That's probably simple enough that you don't need to say it's the number of years times 12 times the monthly payment, right? But it does require documentation there, okay? All right, so again, you've got an abstract class and all of these things except for demo. There's what it should look like. All right. Now, what are we going to do next time? We're going to get even more abstract. An interface is an abstract class with no implementations whatsoever. In fact, we've got several examples here. Navigatable set, sorted set, all of these things up here are interfaces. they do not define anything other than function signatures. For those coming from a C background, it's kind of like having prototypes, right, without the implementation. For those coming from a Python background, there is no such thing in Python. Even though Python has classes, it is not object-oriented, and it really doesn't have true inheritance. Right? It has ex nihilo inheritance, which is not what you want. Right? All right. So we'll continue that on Monday, I guess.